Hello, good day. My name is Nancy Zurita. I am from the Universidad Michoacana de San Nicolás de Hidalgo, and I'm going to present this issue. My poster is about the design of advanced Mof-Based composites for Naproxen removal in wastewater. Okay, I'm going to start saying that the US Environmental Protection Agency defines emerging pollutants as new chemicals without regulatory status and which impact on environment and human health are poorly understood. Emerging pollutants are new products or chemicals without regulatory status and whose effects on environment and human health are unknown. Also, these emerging pollutants are characterized by high persistence, low degradation, and with adverse effects on health and environment, as I said before. Among these contaminants, we found drugs, several drugs, as naproxen and paracetamol or acetaminophen, between many others. Naproxen is a nonsteroidal anti-inflammatory drug. This is widely used for pain relief, and traditional water treatments are not capable of eliminating this contaminant. This is why it's imperative to develop methods, technologies, and materials that are capable of efficiently remove it. Metal organic structures are materials that present attractive characteristics in wastewater remediation, since they are good adsorbents with great cell volume, porosity, and surface area. This work presents the design of a composite material with graphene oxide, cellulose, and a metal organic structure named MIL88A that allow obtaining membranes capable of effectively treating drugs as naproxen and possibly other emerging contaminants present in wastewater. The membrane was employed to evaluate the naproxen removal from water through the adsorption process. And using UV spectroscopy, we measure the results. These results show that the material can be an option to be included in traditional water treatments in form of functionalized membranes. Further analyses are being developed to identify the mechanical properties and the recuperation after it used. How did we do this material? Well, here in methodology, we observed that the first step was to obtain graphene oxide. Graphene oxide was obtained by the Hamer's modified synthesis. And as we can observe, it's a very known synthesis. And after we obtained the graphene oxide, we also obtained microcrystalline cellulose using as precursor cotton pads. After we had the cellulose and the graphene oxide, we did a composite formed with graphene oxide and cellulose, mixing this material with a 2% of graphene oxide and 98% of cellulose. Also, posteriorly, the MIL88A was done. We obtained the crystals, the characteristic crystals, and we did the membrane with this composition. For observing the removal of naproxen solution, we used the UV spectrophotometry at a wavelength of 262 nanometers. In the results, we can observe that the graphene oxide, the cellulose, the composite, and the MIL88A were synthesized effectively. Also, this characterization was done by Fourier transformed infrared, and we can observe that the spectrograms show the characteristic bands for these materials. Same images can be observed, and we identify the characteristic morphology for the MIL88A crystals. We observe that the fibers of cellulose are present, and we can also observe the composites for the materials. In this table, we can observe the loss of absorbance for each material in the Naproxen solution, with, in an instance, present an absorbance, and posteriorly with the materials, we can observe the loss of absorbance for each material. So we can here see that cellulose, microcrystalline cellulose, was the best material, but the MIL88A with the Celgo composite is the second one. This is because probably the graphene oxide and also the metal organic framework provide some color to the solution. This is why we think that it is necessary to do several further analysis to demonstrate that the material is capable of eliminate the naproxen. So the idea is, as we can observe here in this image, that we can have a membrane that presents the cellulose, the graphene oxide, and also the metal organic framework that can absorb the naproxen or all the emerging pollutants that can be removed by this membrane for cleaning waters. So, well, naproxen, as I said before, is defined as an emerging pollutant. And an emerging pollutant is referred when some chemical and its presence in the environment is not significant in terms of distribution or concentration. They are often unnoticed. So the material and the first evaluations of the materials for remotion of naproxen show that it is possible to reduce the absorbance. Nevertheless, further analysis must be performed in order to identify time lengths and composition to increment the movement of naproxen. And well, this is my work. We are still working for obtaining more information about these composites. I appreciate very much your attention, and that's it. Thank you very much.